All right, ladies and gentlemen, welcome to our flipped learning biconditional, conditional, and converse statements. Our learning target: I can use precise mathematical vocabulary to explain my thinking. If you do not have notes in front of you, make sure you have printed out these notes and you are taking notes along this slide with me as I walk through it. So here's a fancy-dancy table that we should use to fill out as we go along. A warm-up: are the following true or false statements? If yesterday was Wednesday, then today is Thursday. Is this a true statement? Yes, it is. If yesterday was Wednesday, then the day after Wednesday is Thursday, meaning today is Thursday. If an angle is acute, then it has a measure of 30 degrees. Is this true? It can be true, but there can also be something that is not true about this. I can have an acute angle of 12 degrees, so this statement is not always true. If a month has 30 days, then it is June. Is this true or is this false? This is a false statement because not always is it going to be June. If I have a month of 30 days, it is not always June. There are multiple months other than June. We call these conditional statements, meaning if P, then Q. Okay? So the symbols that we use for it is P, then Q. So if I am a teacher, I teach math. Is that correct? Absolutely not. Miss Reed is a teacher and she teaches English. So just because I'm a teacher doesn't mean I teach math. But the converse is true. If I teach math, then I am a teacher. That is true. P is our hypothesis and Q is our conclusion. So if something happens, then in conclusion, this will happen. Examples of conditional statements. So use red to identify the hypothesis and blue to identify the conclusion, then rewrite the conditional statements in an if-then form. So this was supposed to be covered up. It was not, but it's okay because we will survive. All birds have feathers, and you are in Texas if you are in Houston. So identify which one is the conclusion and which one is the hypothesis, and we rewrite it. You should be doing this in your quiz if you haven't already. If an animal is a bird, then it has feathers. If you are in Houston, then you are in Texas. Okay, so we just said conditional statements. If this happened, then this will happen. Now let's talk about what a converse statement is. When we write the converse, we exchange the hypothesis and the conclusion. So let's go back to my example that I talked about. If I am a teacher, then I teach math. So my hypothesis was, if I am a teacher. And my conclusion was, then I teach math. But I said this isn't always true, right? Because Miss Reed, well, she's a teacher, but she doesn't teach math. She teaches English. So the converse of my statement would be switching my hypothesis and my conclusion. So my converse would be, if I teach math, then I'm a teacher. So converse, if Q, then P. Remember that conditional was if P, then Q. So for example, conditional, if it is raining, then the grass is wet. What is the converse of this statement? If the grass is wet, then it is raining. Okay, biconditional. Man, there's a lot on this screen, so let's go ahead and get through this. When a conditional statement and its converse are both true, then we can write them as a single biconditional statement. Biconditional means if and only if. So biconditional, P, if and only if, Q. For example, my conditional statement is if two lines intersect to form a right angle, then they are perpendicular lines. My biconditional statement is two lines intersect to form a right angle if and only if they are perpendicular lines. Okay? So maybe a biconditional statement for me is, I will go skydiving if and only if I am paid more than $1 million because I'm very afraid of heights. Okay? Let's put it all together. Let P be, you are a football player, and Q be, you are an athlete. Write each statement in words and determine whether it is true or not. Our conditional statement, P, then Q. Our converse, if Q, then P. And our biconditional, if, so P, if and only if Q.